Hello and welcome to Task 7.2D. This program is designed to generate a minimal 800 moves of tic-tac-toe to provide full insight into the winner and loser, or if it's a tie. To start, I'll show the variable name prefixes. If a variable starts with one of these lowercase letters, that tells you what type it is. Local variables will be in lowercase and global constants will be in uppercase, except for the first character in the name. Moving on, here is what the values on the game board represent. Note that X and O are the only values that are non-empty, and the rest represent empty places on the tic-tac-toe board. P of A, for example, will represent the probability of that player moving on that location. Now here we can see the indexes for how the spots on the game board are stored. Here we can see the default positions of the game board, which will line up with the constant array A, B, C. This will run parallel to our C set array. Now here is the first record in our set. It starts off with all values being null and generates the rest of the records from a null set. Next, the program will check if it is possible for the current player to win on their next turn, but we don't have to do that for turn 3. Because there are 0 possible moves where the current player can win on their next turn, we call this case 0, and the program will automatically call the function symmetry. The booleans you see are initialized as true, and the program will compare all the values marked as the same color star as you can see. This is quite a rudimentary example, as all the values are the same. We cannot possibly end up with anything different, which means all 4 lines of symmetry will be present. Next, the program will set all non-empty areas to their corresponding value in the constant array A, B, C. Next, if the horizontal symmetry is true, then it will copy the top row into the bottom row. Note that this horizont is not a spelling error. I wanted the symmetry booleans to be all the same number of characters in their name, just because. Next, if the vertical symmetry is true, it will copy the left column into the right column. Next, if the downward sloping diagonal symmetry is true, it will copy the top 3 corner values into the bottom left 3 corner values. Finally, if the positive slope symmetry is true, it will copy the top left corner values into the bottom right. This is our final product. As far as playing the game is concerned, we assume that each spot has an equally likely chance of the player placing their move on it, meaning that the probability of A will be 4 out of 9, the probability of B also 4 out of 9, and because E only has 1 spot, the probability of E will be 1 out of 9. Next, the program will compare C set to the constant array ABC and create a new record for any values in C set that are parallel to ABC. This allows the program to only create a new record for a single unique move. We assume, for instance, corner moves are not unique because if you go in the top left corner and rotate, you will end up with the same move. Now we can see level 2 of our probability tree, and these are the 3 that will be created. Note that we name these based on the move history. For each of these, the program will call the function symmetry. We will look at the function symmetry execution for sname of A. Automatically, we can see that the blue and red values are not equal, so we set the appropriate booleans to false. These will not be set to true ever again during this procedure call. Now we can see that orange has also been set to false. Now that we have all our booleans, we will now again set every empty value to their corresponding value in the constant array ABC, like so. Because the negative slope diagonal symmetry ended up being true, again we copy the top right corner values into the bottom left. Now let's assume that the next player moves in position B, and then we will assume that the first player moves in position E. The computer will look at all columns, all rows, and the two diagonals, and we'll have a variable for each of these. It will increase the count by 1 if it runs into an X, decrease the count by 1 if it runs into a 0, and do nothing if it runs to anything else. If we run into one value of 2 by the end, that means this is a case 1. When a case 1 is found, it will set all empty values to L, standing for lose, and will find the appropriate diagonal within superset and set the empty value within that diagonal to its appropriate value in the constant array ABC. Now let's assume player X moves in position D. The program will run the same procedure again to check to see if X can possibly win on their next turn. It finds that there are two possible moves where X can win on its next turn, guaranteeing a victory. In this case, it simply sets all empty values to lose, and the game has been complete. Based on our assumption that the player will block if the other player can win on their next turn, if we have not reached a case 2 by turn 5, we assume the game is a draw. This concludes the video. I hope you enjoyed it.